In this session, we will solve matrix chain multiplication, which is an application of dynamic programming. We have already seen an introduction about dynamic programming and how dynamic programming works. Let us solve the problem of matrix chain multiplication using dynamic programming. We all know what matrix multiplication is. Two matrices A and B can be multiplied if and only if certain conditions are met. What are the conditions? The number of columns of the first matrix and the number of rows of the second matrix should be same. If this condition is met, only then the matrices A and B can be multiplied. So assume the multiplication. So the first row of the first matrix is multiplied with the first column of the second matrix, and we get this result. Similarly, the first row of the first matrix is multiplied with the second column of the second matrix, and we get this. Similarly, the second row of the first matrix with the first column of the second matrix, and second row of the first matrix with the second column of the second matrix. So after multiplication, the dimension of the resultant matrix will be 2 into 2. So this 2 into 2. This 3 won't be considered in forming the dimensions. But how many number of multiplications are being done here? 3 plus 3 6 plus 3 9 plus 3 12. So how will I obtain this? It is 2 into 3 into 2, which is 12. There are some basic properties in matrix multiplication. They are: the matrix multiplication is not commutative. That is, product of or multiplication of A and B is not equal to multiplication of B and A. But matrix multiplication is associative, in the sense, if we have three matrices A1, A2, A3, multiplication of A1, A2 into A3 will give you the same result if you multiply A1 into A2, A3. So what do you infer from this? This is called parenthesization. The way in which you parenthesize. So this parenthesization does not change the result value, but the changes will be there in the number of multiplications that you do. This matrix chain multiplication is a problem wherein you will be given set of dimensions P0 to Pn, which are corresponding to the matrices A1 to An, where Ai has a dimension Pi minus 1 into Pi. And we need to determine a multiplication sequence that minimizes the number of scalar multiplication in computing multiplications of matrices A1 to An. That is, we have to determine how we are going to parenthesize the multiplication. So if there are four matrices A1, A2, A3, A4, there are different ways in which you can parenthesize. So this 2 can be multiplied first, this 2 can be multiplied second, later on you can multiply these two. Or else A3, A4 can be multiplied first and then it can be multiplied with A2 and then with A1. Or else A1 and A2 can be multiplied first, then with A3, then with A4. So these are the different ways by which you can do your matrix multiplication. So how am I going to group it or parenthesize it? That determines the number of matrix multiplications which I am going to compute. And our intention is to have minimal number of multiplications, and that is successfully done with the help of dynamic programming using parenthesization. So when I use exhaustive search, that is my brute force methodology, and if I want to compute matrix chain multiplication, the complexity will be 4 power n, which is exponential. And Do we have any better approach so that this complexity can be reduced? The answer is yes. It is nothing but our dynamic programming DP. So in dynamic programming, we are going to determine the structure of an optimal solution, that is parenthesization in our case. So we will decompose problem into smaller sub-problems, and then we will use the results of these sub-problems in calculation of the solution to the main problem. Let us move into an example for solving matrix chain multiplication. Suppose you are given a sequence 4, 10, 3, 12, 20 and 7. So what are these? These are the positions. This may be represented in an array. These are the positions, and with these positions we can frame dimension of a matrix. That is, A1 will include the first two, A2 will include this, A3 will include this one, A4 this one, A5 this one. So with these positions you can frame the dimension of the matrix. Throughout the entire problem we are going to use this formula only. So we all know in dynamic programming we will be using the solutions of the sub problems. So that concept has been utilized and this formula has been framed. Initially we will draw a matrix. Since we are dealing with multiplication of 5 matrices, here also 5 and here also 5. Initially mi of I will be 0. So that is why diagonally I have placed all zeros. Next we need to calculate product of two matrices. Since we are going to solve from smaller problems, we will calculate the product of two matrices first. So we have formulated this matrix already. So all these are filled with 0. Now I need to find 1, 2. So how to calculate 1, 2? So apply the same formula. Here k will take the value from I to j, including I but excluding j. So here I is 1 and j is 2. So k will take only one value, that is 1. So applying this formula you will get m of 1, 2 is minimum of 1 less than or equal to k less than 2 m of I k. I told you k will take the value 1 only. So I comma k is 1 comma 1 and then I plus k comma j. So I is 1, 1 plus 1 is 2 and j is already 2. And here the positions pi minus 1, pk and pj. I is 1, so 1 minus 1 is 0, k is 1, so p1, j is 2, so p2. So we have these values for p1 and p2 already given in the problem. So when I solve this, it will be m of 1 comma 1 and here it is m of 2 comma 2. We already know that 1 comma 1 is 0 and 2 comma 2 is also 0. So these two values will end up with 0 and 0. So we need to multiply only p0, p1 and p2. So when we multiply, we will get 120. Similarly, we need to find the value of 2 comma 3. So similarly, when you apply the same formula, you will get zeros for the values of mik and mk plus 1 comma j. You need to multiply only the values of pi minus 1, pk and pj, which is nothing but p1, p2 and p3. So that is why p1, p2, p3 is multiplied and we got 360. Similarly, we need to find 3, 4 now. So matrices, two matrices will be there. Those values will be 0. So straight away you can multiply the values of P2, P3 and P4. P2, P3, P4 to get 720. And the last option is m of 4 comma 5. Here also directly we can multiply P3, P4 and P5 and we get 160. Sorry, 1680. So these values have to be filled inside this matrix. So it will be 120, 360, 720 and 1680. Now let us move on to calculation of product of three matrices, and for this calculation we will be using these sub problems solutions. So calculation of three matrices, same formula, all the values of P0 to P5 is included here. So we need to calculate matrix of 1, 3, and for that we need to multiply M1, M2, M3. So there are two cases, two possibilities or two ways of arranging multiplication. Either M1 and M2 can be multiplied, after that it can be multiplied with M3, or else M2 and M3 can be multiplied first and then it can be multiplied with M1. So there are two possibilities. So you apply the same formula here. Now K will take the value 1 and 2 but not 3. So we have to write this formula twice and we have to find out the minimal value. So I is 1, J is 3. So K will take the value 1 and 2. So if K takes the value, this is the formula, and if K takes the value 2, this is the formula. After applying the values, we get 264 and 840. Now M of 2, 4. So this time we will be concentrating on M2, M3, M4. Here also there are two possibilities of multiplication. Either this first followed by this or this first followed by this. So apply the same formula. Now I will be 2 and J will be 4. So K will take the value 2 and 3. If K is 2, this is the formula, and if K is 3, this is the formula. Applying the previously calculated values, we will get 2760 and 1320. And the next is M3, 5. Here we are going to multiply M3, M4, M5. The two possibilities of multiplications are given. I is 3, J is 5 and K will take two values 3 and 4. When K is 3, this is the formula, and when K is 4, this is the formula. So we will calculate the values as 1140 and 1930. So those values are entered in the matrix. Next, so those values, but minimal values only has to be filled. We should not take both the values. Only the minimal value has to be filled here. Now calculate the product of 4 matrices. So initially we started with product of 2 matrices, then 3 matrices, then 4 matrices now. So the 4 matrices we are considering are M1, M2, M3 and M4. So how many possibilities or how many ways of parenthesization? So there are 3 ways. So like this multiplied by this, or this multiplied by this, or M1, M2 multiplied with M3, M4, like that. So there are 3 cases, 3 possibilities. So apply the formula. M of 1, 4 is, now I is 1, J is 4. So K will take the value 1, 2, 3. So when K is 1, this is the formula. K is 2, this is the formula. K is 3, this is the formula. So I will get 3 values and I have to choose the minimal one. That is this one. Next, I need to find 2, 5. Here matrix 2, 3, 4, 5 will be considered, and again there are 3 possibilities of parenthesization, and I is 2 here, J is 5. So K will take the value 2, 3, 4. So these are the formulas when K is 2, when K is 3 and when K is 4. So these are the possible values. Out of this I have to select the minimal one. Now I need to calculate for 5 matrices. So apply the same formula. same set of P0 to P5. The matrices which I am considering are from M1 to M5. Now there are 4 possibilities of parenthesization which are listed as below. Now I is 1, J is 5. So K can take the value 1, 2, 3, 4. So applying the formula, when K is 1, K is 2, K is 3, K is 4. These are the values, and out of this I have to select the minimal one, and the minimal one is 1, 3, 4, 4, and that has to be filled in this column. With this we have found the matrix multiplication of 5 matrices, and we have identified that 1, 3, 4, 4 scalar multiplications are done or calculated when I am multiplying 5 matrices. But now I need to say in what way I have parenthesized so that I got this 1, 3, 4, 4. So we have already found the minimal one is obtained when I'm taking M12 and M35. So 1, 2 should be multiplied and then 3 to 5 should be multiplied. So this is the one I have identified. But in the previous steps, I have already computed 3, 5, which is 1140. So when I am multiplying matrices from 3 to 5, there are 2 possibilities we have seen. One is multiplying 3, 4 and with 5, or else multiplying 4 and 5 and then multiplying it with 3. So of these, this only produced the minimal number of scalar multiplication, that is 1140. So I am using that for this calculation. So my final parenthesization is M1 M2 multiplied by M3 M4 multiplied by M5. So if I group or if I parenthesize the matrices in this way, then the number of scalar multiplications to be done is minimal, and it is 1, 3, 4, 4. Hope you understood how to perform matrix chain multiplication. In the next slide, we will see the algorithm and its complexity. So this is the algorithm based on which the matrix chain multiplication is done, and all the formulas that we have used is written here. Coming to the complexity analysis, here we have 3 for loops, one for length, one for I, another one for k, and all these loops are iterated n times. So based on that, the time complexity is order of n cube. In exhaustive search, we have seen it in exponential terms, 4 power n, but now it has been reduced to order of n cube. We will watch some more examples of dynamic programming in the next video.